my name is Jonah Flint. This is my Physics 2212 Lab 1 report. For the introduction, we use Scotch tape to observe the transfer of electrons between two surfaces and estimate the number of electrons transferred. And then for our fundamental laws and equations, we used Newton's force equals mass times acceleration, Coulomb's law, and then we used a couple constants. Coulomb's constant K, right over here, 1 over 4 pi epsilon naught, and the charge of one electron, and then we also use the approximate dimensions of one atom. Quick preview to our results here. We found that charged pieces of tape repel one another, and we also found that both pieces of tape were positively charged. And then we found that the charge on each piece of tape was around 1.34 times 10 to the negative 8 coulombs, and each piece of tape lost about 8.37 times 10 to the 10 electrons. Some key assumptions in our model were that each piece of tape was modeled as a point charge, that's just for simplicity, and then we decided to ignore air resistance and friction. And we also assumed that each piece or each U-tape was, it held the same charge, and the charge was evenly distributed across the piece of tape. For the actual experiment, we decided that the system was just going to be the two pieces of tape, and everything else was the surroundings. The initial conditions were that the tape had no charge and all the pieces were the same length. And for our procedure, we just stuck one piece of tape to the table and adhered a piece to the top of that. We then ripped the two pieces of tape apart, which gave the top piece of tape a charge. And then we used that charged piece of tape to do some experiments. So for our experimental results, we found that the tape had a mass of 0.002 kilograms. Each piece of tape had a length of 0.2 meters. The tape width was 0.19 meters. And using the mass, we found that the force due to gravity was 0.00196 newtons. And then we found that the tape charge, using this equation here, was 1.34 times 10 to the negative 8 coulombs. And then we found that the number of electrons lost by each piece of tape was about 8.37 times 10 to the 10 electrons, and we simply found this by taking the area of the tape and using the number of atoms in that area, and then the ratio of electrons to atoms. And in our glow script model here, we found that the number of deficient electrons per piece of tape was this long number here, which is in conjunction with this number here. So you can see they're relatively similar. The order of magnitude is correct, but obviously we're dealing with great scale here, so there is going to be some difference. And then we found that the number of atoms was this long number here, and the ratio of deficient atoms to electrons, or deficient electrons to atoms, is about this ratio right here. In our models, we're simply setting our initial conditions up here, finding the gravitational force, which we then use to calculate the electric force, which we then use to calculate the charge, and then we find the number of deficient electrons, the number of atoms, and then finally the ratio down here. And this is simply for the animation. Some possible sources of error. We're not actually using true point charges here. And then we are, it's not likely that the charges on each piece of tape are equal. And finally, the charges could differ between the pieces of tape, and there may be some charge dissipated during handling. For the what ifs, what if the electron had a positive charge, or what if the electrons had a positive charge and the protons had negative charge? Our observations would stay the same, as like charges would still repel and opposite charges would attract. And for the why, it is important to not handle the tape as much as possible, because when we handle the tape, when we bring our neutral hand into contact with the tape, some of the charge can be lost in that exchange. Thank you very much.